morning, good afternoon, or good evening, depending on where you're joining us from today. Welcome to 5G Things Dialogues. My name is Brian Heath, and I lead marketing for the AT&T account here at Ericsson. Today's event, focused on mining, is hosted by D-15, which is one of Ericsson's innovation centers. This is located in Silicon Valley. At the end of the day, innovation is the heartbeat of what we do at D-15. We also focus on thought leadership and co-creation, really around a couple of key areas, 5G and Industry 4.0. Some of the projects that I'm excited about that I've seen are extended reality projects, IoT, holographic communications. Today's focus, again, is on mining specifically. We'll take a deeper dive on mining in a connected world. We'll start out with an overview of a report that Ericsson released in December of 2020, which talks about private cellular technology, how that can improve safety and productivity for workers in mining organizations. Philip Mestinov of Ericsson will join us, and he'll talk about 5 specific use cases for connected mining. He'll talk about autonomous vehicles, remote operations, monitoring and tracking, enhanced video services, and hazard and maintenance sensing. After Philip, we'll have a panel of industry-leading experts who will share their views as well. We've got experts from AT&T, Ambra, Epiroc to share their views, and the session will be facilitated by Per Trevin from Ericsson. On behalf of everybody at Ericsson, I want to thank all of you for joining today. Want to thank Robert Wojnowski with AT&T, Philip Mestinov from Ericsson, again, Per Trevin from Ericsson, who's leading the discussion, Eric Leroux from Ambra, and last but not least, Robert Wojnowski from AT&T. The panelists will share more about their roles and background as we kick off the event, and then we'll have time at the end of the session for Q&A. I would encourage everyone to use the chat functionality, chat with each other, share your Q&A, and then we also have links for our social media profiles in the tool as well. So feel free to engage with us and talk with us on social media as well. With that, I'd like to welcome Philip Mestinov from Ericsson to kick us off.
Yeah, thanks, Brian. So welcome, everybody. My name is Philip Mestinov, and I work as an industry and ecosystem manager here at Ericsson, focusing on the mining vertical. So I thought today I can just give you a brief taste of what the Connected Mining report that we have recently released is all about. And I thought like the best way to start is if we talk a little bit about mining 4.0 and what that is. I guess a lot of you might have already heard about Industry 4.0, and that is pretty much the same concept, just applied to mining. When we look at the 4 different industrial revolutions, there is obviously a lot that has happened in the last 150 years. With Industry 1.0, where water and steam power enabled a lot of productivity increase within the mining industries and other industries, through Industry 2.0, which was the second industrial revolution. Well, electricity and mass production further increased productivity and enabled us to do things a lot more efficiently. Then later on, when electronics first start influencing the different industries and automation became mainstream in most of the industries, then the game completely changed. And we see pretty much the same thing happening today with Industry 4.0 and Mining 4.0, where we envisage these cyber physical systems where we have mass digitalization. So all kinds of different assets get connected to the network, and then information gets exposed to the digital domain. Processes get revamped and redone in order to increase productivity, efficiency, but of course also reduce environmental impact and improve safety of the workers working in those mines. So this is pretty much what we're talking today, and this is how we see the mining industry evolving in the next years. So hopefully we can help realize the vision of Mining 4.0. And what we see as a crucial part of this is stable communication systems which provide reliable connectivity within the mines. And that is where Ericsson comes into the picture with our private network solution. So this is the rock-solid 4G and 5G connectivity. This solution has been built with the same technology that is deployed by mobile operators worldwide, and this is currently being used today to carry the network traffic of more than 1 billion subscribers all around the world. What we did here is that we took our leading portfolio in telecommunication services and adapted that for industrial use by scaling down, by developing specific type of features, by further improving availability, reliability, and then obviously ruggedizing the equipment when it comes to the mining vertical. So this is a business and mission critical grade 4G and 5G solution, and this is also a solution which is used by first responders in different countries. So this is very well fitting with the needs of different industries, mining being one of them. Since we are here leveraging the entire portfolio that Ericsson has, both in terms of radio but also digital services, we have a lot of flexibility to provide different types of solutions depending on the need of the end customer, together with a mobile operator such as AT&T. We could provide full on-premise systems if that is what is needed for a particular application. Of course, we can provide systems where part of the system is located with the enterprise on-premise, and part of the system is located with the mobile operator off-premise. And all of these options are obviously available through the same solution, and this solution can be further scaled up and down depending on what is the current needs of the enterprise. Now, when it comes to mining in particular, what we did together with our partners within the mining industry, such as Epiroc, Komatsu, Modular Mining, and others, is to identify use cases which the mining industry sees as providing biggest value. So obviously, technology is out there and it's mainstream. However, a lot of mining enterprises today are facing a whole array of challenges, how to start and what is the return on investment, shall they decide to deploy LTE, 4G, and 5G networks and are for their particular use. So what we did is we talked to our partners, we did this work together, and we identified 5 key use cases, which then we have further elaborated, both in terms of the technology requirements which these use cases set out there, but also build a business case around each of these use cases. So these 5 use cases are autonomous vehicles. This is pretty much a mainstream technology deployed in quite a few mines today, so this is obvious value for the end customer. Then we have remote operations, for example, remote control of drilling rigs or remote control of charging and blasting equipment and other such use cases where it's not optimal to have people on site. Maybe the area is dangerous, maybe there is some other reason for the machine to be required to be operated remotely. Then we have another use case, which is real-time condition monitoring, where we can monitor all kinds of assets within the mine. Obviously, we can monitor the people within the mine to track their location, to see if they are potentially entering an area which could be hazardous, to be able to communicate with the workers in real time, but also to be able to track machinery and other assets within the mine, and be able to do advanced things such as predictive maintenance, where we can actually see if an equipment has a chance of getting downtime, and we can react proactively instead of reacting reactively once the downtime has happened. Then we see a lot of use for drones in mines, both open pit and underground. Obviously, there is a lot of things that drone can do. For example, if you have a blasting event, before the area is cleared for humans to enter, a drone can actually fly in and do initial assessment of the situation and also map the area using LiDAR and similar sensors. Smart ventilation, especially for, well, obviously for underground mines, is a particular use case of interest, since the electricity consumed by ventilation systems in underground mines could actually amount to up to half the whole electricity bill for a particular mine. And the potential for improvement is also quite large. You can save up to 60% of that cost if you deployed smart ventilation systems underground. So all of these 5 use cases, obviously they have been identified as high value to end customers. So what we did together with our partners is to build business cases around those. So how much is going to cost a particular mining enterprise to implement those use cases, including the cost for providing the network, the cost for implementing the use case end to end, And we obviously track the upfront investment as well as the recurring OPEX charge that is required to be able to run some of those use cases. And we have matched that towards the savings that you can get when you deploy these use cases. And we build the value around each of those use cases. And that is some of the resources that we have released out there. So we have this value calculator where you as an enterprise or you as an interested party, you can enter there, and then depending on the size of your mine, the production capacity of that mine, the number of machines that you have, we can build a business case tailored for your particular mine. So if you decide to implement one of these use cases or several of these use cases, how does the return on investment look like, and then what is the payback after 5 and after 10 years? And it is obvious if you have more use cases implementing over the same infrastructure, then the cost is shared between the use cases, the upfront cost required to enable them. So the more use cases you actually enable and implement, then the better value you get out of that. So this is a pretty interesting tool to be able to get an idea of, if you'd like to jump on the bandwagon of LT and 5G in the future, what is the business case for that? Then it's much easier to justify the initial investment. So apart from the smart mining value calculator, which we have released, we also have a connected mining report, which is then elaborating in a bit more detail on each of these use cases, and then providing a bit more detail of what is the background to them, how does it actually work in practice, what is the benefits, how do we quantify the benefits, and so on and so forth. So if you'd like to read that, if you have not done that already, there will be a link included here in the presentation. So please feel free to download that and have a look at that, and reach back to us in case you have any questions. And we are super excited about this. We see a lot of great things happening out there in the industry. So we see that this is a great market, which we together with our communication service provider customers are enabling and helping to address. And then I believe now we have a small poll for the audience. So if Brian can help me run the poll. So yeah, there is the poll. I guess you should see that on your screen. Please have a look at those. We're basically asking you which is the use case that you think has the most business potential in your own opinion, whether you're a mining enterprise or you're working with the mining enterprises. We would love to hear some feedback from you on how do you see, where do you see the biggest value, and which is the use case that you think is most impactful. And here we have the autonomous load, haul, and dump. We have the remote control drilling rigs, the real-time condition monitoring, the unmanned drone inspection, and the smart ventilation control. And I can see some of the answers are already rolling in. And I will allow for a bit more time for the rest of you to engage. Okay, we have a 1/3 participation and still going up. Happy to see that a lot of you today are engaged in this session. That is always great to get some feedback from the audience and have a bit of a interaction in these webinars. Okay, we have almost half the participants that have responded. And I think the responses are slowing down, so I will just reveal the result of that poll. Let's see which is the winning use case here. Well, it's quite a good distribution. Obviously, real-time condition monitoring, that is great. That is something that is actually a good starting point, and autonomous load, haul, and dump, as I mentioned, pretty much a mature technology nowadays, so that is where we see most impact and most potential value. Great, thanks a lot for that. And now I hand over to Per, who will be leading the session from here on.
Thank you very much, Philip. So we are going into the fireside chat. And as we are going in and starting with the questions, before that, I'd like to introduce our panel. and it's Robert with AT&T, Tim Ledbetter with Epiroc, and Eric Leroux with Umbra. Thank you very much for joining us today and this fireside chat related to connectivity in mining. You all represent companies that enable connectivity end-to-end for the mining ecosystem. And we will explore a bit the role that you play in this ecosystem and what it means to you. Before we dive into the conversation, it would be great if you can introduce yourselves and tell us what your role is within each of your companies. So let's start with Robert first, and then Tim, and then Eric. Robert, please go ahead.
Yeah, thanks, Per. Thanks, Philip, and the introduction was great. Thanks for having us and putting us on. I'm Robert Wojnowski. My home office is here in lovely Dallas, Texas. Hopefully I get my COVID shot this week and I'll be back in a building near you at some point. I host or manage the IoT and mobility practice for enterprise customers for AT&T Business. And we serve everyone from small business up to global enterprises with digital solutions, including private networks, which is today's topic in 5G. So thank you for having me.
Great, thank you. Tim?
Yeah, thanks, Per. It's good to be here. I as well am coming from my home office in a suburb of Dallas, Texas. And I am the Vice President of Automation, Research and Development for Epiroc Surface Division. So I had the responsibility for the automation on all our surface products that we build. So we build very small drills that'll drill 1 to 1.5 inch diameter holes in construction environments, all the way up through our large surface mining pit viper class machines. So everything from, a 3,000 kilogram to a 200,000 kilogram product. So the responsibility for the automation for those falls under me. Thank you.
Thank you, Tim. Eric?
Yep. Thanks a lot, Per. My name is Eric Leroux, telecom engineer and CEO of Ember Solutions. I'm from Montreal. So Ember Solutions has been deploying mission-critical wireless networks for mining for the past 15 years. And up to now, we've been covering over 500 kilometers of underground mining tunnels with 4G and 5G technology. So I'll be more than happy to share with you some of our findings that we've done.
Thank you, Eric. And for the participants, please put the questions that you may have in the Q&A section in the meeting. So we will start off with some questions here, but I hope that you will have questions that we can address as part of this fireside chat as well. We will start with Robert. And Robert, how does AT&T see the industrial digital transformation advancing in the U.S.?
Oh, wow, Per. I think the innovation over the last 12 months has really accelerated. As folks like you and me and our colleagues on the phone stare at each other, stare at our dogs, stare at our walls, trying to figure out what to do with our time, we start thinking about innovation and creating that next digital transformation. And so it's really advanced over the last year or so. And I think for us at AT&T, we've been on this journey for a while with our enterprise customers. We serve just about every single Fortune 1000 in some capacity, whether that's a fiber-based solution or wireless or IoT. Our business is pretty vast, and every single business, every single vertical is on a transformation. It's like transform or die, right? So we're on this journey together, and I think we're looking at new technology, and I think the setup slides give you a sense for some of the use cases that are very germane to the mining sector. And you think about some of the robotics and automation that's going on, the predictive maintenance, the security aspect of it too, right? There's a lot of technology out there, video surveillance, AI, ML, that's going to help keep our workers safe and keep the operations humming. And I really like the fact that Philip had this kind of business case calculator, because we're still early on in this evolution of the 4.0 transformation in mining, or the manufacturing 4.0. And a lot of industries are struggling to justify some of the investment in technology. Like, in your gut, you know you need to transform, or your competitor will, but how do you go prove that internally? And you've got to prove that internally by justifying the expense, your capital request or OpEx request in your own department. And so having tools like that, coming from Ericsson, coming from AT&T, and be able to sit down with partners that have experience means the world to our enterprise customers. So there's a big portfolio out there, and it is still early. I don't think the entire ecosystem is completely put together, but there's a lot of enablers that are going in the ground now, right? The capital investment is very large right now for us and our partners on the call to meet the challenge of this digital transformation that's going on right now.
Thank you, Robert. My next question is for Tim. And as Robert talked about the digital transformation, what demands do you see from the mining industry for wireless communication? And how do you see that 5G-ready cellular networks can solve this demand?
Yeah, thanks, Per. As Robert said, you mentioned that the technology is accelerating. And we see the same thing with our mining partners, that the connectivity requirements in mining it's increasing at an exponential rate. Today, the miners want all of the mobile assets to be connected to the wireless network for dispatching reasons, for preventative maintenance systems, and general streaming data requirements off of those mobile assets. That's really driving the need to have a higher bandwidth to support all the assets and the sensors that are being connected to the infrastructure in a mine. The modern mine it's loaded with sensors, and they just keep installing more and more sensors to get the value out of them. So it's really the Internet of Things approach. There's sensors for ground monitoring to measure ground movement. There's tailings dam monitoring. There's ground vibration sensors. There's several of them. And then if you get into the next phase, into automation, I'm passionate about automation. It's what I do. So I was going to talk a bit about it today. But as Eric said as well, he mentioned the term mission critical network. And that's what happens when you start to venture into the automation. Dark spots in the network and high latencies, they just will not be tolerated by the state-of-the-art automation systems. I was in a NIOSH seminar on autonomous mining safety, and a project manager for autonomous mining from Nevada Gold Mines, he brought up that in his experience, the IT team at the mine should have a KPI of tons hauled, not latency or anything else like that. They should have a production KPI. And that just shows how critical it is to have that bandwidth and mission critical connectivity. 5G brings the technology to help ensure the mission success when you have this mission critical connectivity with the bandwidth and the low latency and the strong quality of service. Those are huge factors for doing autonomous haulage or autonomous load halt dump, as well as 5G has enhanced security and also handoffs as a truck passes from one tower to the next. The handoff is managed more seamlessly than it is in the Wi-Fi environment. So yeah, so those are a few things that we're seeing for wireless connectivity in the mining space that 5G can help us with.
Great, Tim. Thank you. So Eric, when meeting this demand from the mining industry, what do you see as the main challenges when installing a new 5G-ready dedicated network, and what do you see are some of the showstoppers?
Well, there are a few, actually. First of all, as you know, a mine works 24/7. So, I mean, having access to the equipment, bringing a new technology means it's pretty limited the time we can stop production. So there's always a challenge. And as you know, every new technology comes with risk. So in the mining, nobody wants to be first. Everyone wants to be second. You want to make sure that the technology has been tested and it's been working well. And today, I'm glad to say that we're now here. So we have those initial deployment that's been done. We've been proving that this technology is working very well. So this is really something which we see as a challenge. But really the biggest challenge is definitely related to the RF radio frequency. So really that mission-critical network must be reliable, redundant, and provide enough throughput, and of course low latency. So really, we see out there like application like push-to-talk, VoLTE, Modbus, Profinet. They don't need a lot of bandwidth, but they need a really robust network with low latency, high security. So that's why we need that quality of service to make sure that those critical signals, such as like emergency stop, are delivered on time on the network. But as you may know, like designing a 5G ready network is completely different in a mine than designing for like a public network typically, because most of the traffic will be on the upstream. So you have, by the way, cameras mounted on trucks and on machine uploading video feed in real time. So this is where we see the challenge actually. And we see that challenge both for open pit and underground. It's really different challenges, though. So that's why we had to spend years in underground mines to see, okay, what is the RF propagation? How does it work? How can we ensure high bandwidth at the phase where we have those machines operating? So this is really what we've seen in terms of RF. And of course, when it comes to RF, it means that spectrum. So it's always related to spectrum. So is there spectrum availability for a specific location? So that's what we've seen could be a huge showstopper for some of the countries, or maybe for some of the areas, congested area where the mine is located close to a city. So those are the showstoppers that we see right now.
Thank you, Eric. Let's go back to Robert and talk a bit more about the portfolio and how some of these needs can be addressed. So, Robert, with enterprises increasingly seeing the return on investment make sense to invest in connectivity solutions, what is AT&T's portfolio strategy to address such dynamic use cases, commercial requirements, operational requirements?
I was waiting for that to happen. You know, it's National Puppy Day, but I'm glad your cat is making a cameo appearance here and not taking a back seat.
Yeah, he got chased by the puppy.
Yeah. Look, you got to be flexible in COVID, right? Your question was around ROI, connectivity solutions, kind of our portfolio. Let me unpack that with a couple of different answers. I really liked what my colleagues just said, right? Tim and Eric, especially on the RF challenges, okay? None of this works unless you have coverage. And going underground to provide coverage isn't trivial, right? You know, being an AT&T, I get a lot of questions to come speak around 5G. How fast is it? Multi-gig speeds on millimeter wave, things like that are interesting. You know, AR, VR applications, like what's the next killer app, right? But when it comes down to it, coverage is king. Connectivity to the endpoint is what matters here. And you've got to be able to provide that coverage in the strangest locations in the mining business, right? Above ground, underground. These mines are not in, major metros, right? They're in remote places. And so we've tackled that with just a portfolio view and a partnership view. Frankly, we knew we couldn't solve this by ourselves, so we asked Ericsson to come help build out our product set. And so at AT&T, we bring forward in-building solutions, so inside the four walls with distributed antenna systems and bringing our spectrum to bear. We have multi-access edge compute technology. We've been in market for 2 years on that, really making the market at AT&T, which gives the control and security that enterprises need, mining companies need, frankly, to manage their business, their mission-critical business. And it removes all the latency hops to our core network because we drop our software core on-prem. Very key technology. And it starts with LTE. You don't have to wait for 5G for that. Private cellular networks is what we're talking about here, and why we enlisted Ericsson's support with your industry-leading product set. So when we don't have our fiber-rich landscape to go build our cellular network off, we can roll in our private networks on CBRS. And then our private cellular networks, basically mobile team, right? We have the ability to roll in, roll out networks depending on what the site calls for. So from our perspective, we try to cover as many of the use cases environmentally as possible. And then from a spectrum position, we hold low band all the way up to millimeter wave, high band spectrum. And we just spent some money on the mid-band auction, as you guys know, to really grow with whatever the customer's bandwidth needs are going to be. But very simply, this usually starts with upstream network design, which is really important. It's not a down game, it's an up game when you think about what we're doing here. Control and building the network with security. Those are kind of the key elements that we wrap around our solutions when we engage with our customers.
Thank you, Robert.
I hope your cat liked that.
Yeah, well, he went out, so
he ran away. That's not good.
He was happy with the answer, and then he left. So we talked sort of about the 5G ready technology and so forth. So Tim, when we are moving from Wi-Fi to 5G ready cellular technology, what do you see are some of the challenges around that?
Yeah, good question. Robert said it well. Connectivity is king. So that's what really the miners are wanting, is that reliable connectivity. Some of the things that we've seen is the mining environment is tough and a challenging industry in general, and the equipment working in the mines needs to be extremely rugged. So when you're transitioning from Wi-Fi to a 5G technology, the selection of a ruggedized endpoint to put on the machines is a bit limited. Luckily, we do have friends like Eric at Ambra that they do develop these ruggedized endpoints, but there's not a plethora of selection like there is with the Wi-Fi. So that's one of the challenges that we see today if you're trying to make that shift from Wi-Fi to the 5G in the industry. That's going to get better as 5G becomes more widely used around the world, in the U.S. and around the world. Another challenge that we've seen doing this is availability of spectrum. I think Eric mentioned that earlier as well. Depending on where you're working in the world, there can be challenges around the availability of the spectrum to work in the 5G range. And another one, this one, my experience is more surface mining than underground. But with our surface mining customers that we work with, we see most of them are using a layer 2 network technology. And they have a lot of systems, legacy systems that require that layer 2 network. When you bring in a 5G or an LTE, it's coming in as this layer 3 solution. That it brings just some technical challenges for the miner to work through as well if they need to maintain the layer 2 legacy systems and bring this layer 3 in. There are some emerging technologies, though, to deal with that are being developed in the industry. But as an OEM, those are some of the challenges we see making that jump from Wi-Fi to 5G.
All right. Thank you, Tim. Moving over to Eric. And so as Tim just talked about some of the challenges as part of this transformation, when you talk to mining companies around transformation, and they would like to enable a 5G ready network, where should they start?
Well, it all starts with a need to be more efficient. So, and a good example is a COVID. So really COVID accelerated the need for some use cases such as tracking and remote operation. So as you know, today one operator can now remotely operate several mining machines from a central point of view. So that's a good example. Now, usually mining companies will start looking at 5G ready cellular technology to enable those new use cases that need more bandwidth and more availability. So mining companies that had Wi-Fi before will choose the LT technology to overcome the limitation of the 802.11 protocol, mostly in terms of coverage and reliability. So for an example, for an open pit mine, the 5G ready cellular technologies will allow to reduce and even sometimes eliminate the need for trailers that needs to be moved every time open pit mining do blasting. For underground mine, the private LT is really a disruptive technology because a single LT radio can replace between 60 to 80 access points. So with one single LT radios, we can cover 6 kilometers of tunnel. So this is really impressive. So with a lower cost per meter than Wi-Fi, those LT networks can provide 100% coverage for underground mines, so allowing the workers to always be connected. So this is really, as I mentioned, disruptive technology, which allow the workers today to do video call, Teams call with their supervisors. So that's something which wasn't possible before. So that's what we see right now.
Thank you, Eric. So, Robert, perhaps you touched a bit on this in your previous answer to the question, and you talked a bit about some of the remote mines. Here in the U.S., maybe they are not as remote as in Australia and Canada, but there's still a connectivity challenge. And how do you see that AT&T can provide connectivity to these remote, challenging locations?
Yeah, we've got several different customers that have some unique challenges for sure. Starts really with, where are we relative to our fiber network? So at AT&T, we've got a vast fiber network. And from there, you can build on top of that your exterior, your RAN infrastructure to go cover a particular mining site. So starts there. The second point is, as you start to think about what you're trying to do within your mining environment, you might have a localized network which is completely closed to the mining environment. Then you got to think about how do you backhaul off of that. And so there's different ways to do that from a technology perspective, but it all really depends on where the customer is and what their needs are. In some cases, you can't trench fiber in the middle of nowhere. It just costs way too much to go do that for very specific single customer, so you can't reuse the fiber. In many cases, there aren't cellular networks out there. So you've got to handle each of these as one at a time. Understand what is there from a macro perspective. Are the fiber assets there or not? And then perhaps you roll in, a completely private network for the customer. In some cases, we've engineered specific cellular RAN systems in and around the environment that are purpose-built for that particular customer, and then connected it back to our network. So it starts with, what are we doing at the endpoint? What kind of connectivity to the outside world is needed, and how are we going to backhaul that data? So it's a very kind of tricky question, but it's one that every customer has to answer right out of the gate, right? It's almost as important as, what are you trying to do with the network, and is there an operational business case for the mining company? It's right up there, right? How do you cover it, and what are you doing with the data and connecting it to the outside world?
Thanks, Robert. Let's go in a little bit on some of the use cases and talk a bit about the safety. And Tim, can you talk a bit about how you see that connectivity can improve safety in mining?
Yeah, for sure. There's lots of different areas connectivity can improve safety. And as has been mentioned, a lot of these are upload heavy, not download heavy, so it's a bit unique for mining. But one of the solutions, and I'll try to kind of put these in order of maturity and adoption, input video systems are very common now. So it's common for dispatchers and others who need to have situational awareness to be able to see who's on maybe a drill pattern, who's not on a drill pattern, is there congestion here or there. So these in-pit security cameras or just in-pit cameras and video systems, they use a lot of bandwidth. So having technology like 5G that can bring a lot of bandwidth to bring a good high-resolution video to the people that need to have that situational awareness will help. There's a lot of products on the market that are collision avoidance systems, CAS. I'll just speak in generalities about them, but most of them do require connectivity. A lot of them, the backbone is that the asset that they're on will report its position, its vector, and with the vector, its velocity. And it takes all that data into a central computer and crunches it, and then it'll send warnings out to vehicles that might have a potential collision based off that data. So having that connectivity, the low latency, and maintaining that connectivity everywhere that vehicle goes in the mine, that's really important for these systems to work. The systems have been evolving to some different communication protocols and methods because of the lack of reliable Wi-Fi coverage in the surface mining. So this is something that 5G can help bolster as well. Another thing that there's some systems in the market is asset tracking and personnel tracking, again, for situational awareness. Not just having the video surveillance, but being able to see on a mine map where all your assets and all your people are. Epiroc's partners, ASI Mining and Mobilaris, both provide solutions for tracking these things, and both of them are connectivity critical, so it's very important. And last and ultimately, the safest way or the best way to increase safety in the mine is to remove the people. So I mentioned it earlier, automation and autonomous. So if you can get the people out of the drills, if you can get the people out of the trucks, they're completely removed from harm if they're out of the pit then. That's one of the biggest advantages of the 5G LTE technology that we see. It's the ability to have that low latency so you can have that full autonomous control. As Eric said with his underground statement, one tower can replace 40 Wi-Fi access points. It's a bit different ratio on surface mine, but similar, where you get more coverage of that pit with less towers to be installed. So 5G will be an enabler to accelerate the adoption of automation, in both surface and underground mining. So those are just a few. I could talk for quite a while, Per, but those are a few that jump to the top of my mind.
Oh, great. So following on the safety track, there are some additional products to complete the ecosystem, such as body sensors and so forth. And Eric, can you talk a little bit about how these work and how they further can improve the safety for workers in a mine?
Definitely. So as Tim mentioned, safety is the most important aspect of mining. So a 5G-ready network definitely improve the wireless coverage, thus allowing mining users to perform emergency call from anywhere on the mine using connected devices such as phone, cap lamp, smartwatches. So now it's pretty common to find body-worn camera for people that are working in confined space. This is an example that we see more often now. For open pit mine, we can now use biometric sensors to detect and prevent accident with low power wearables. We can easily detect man-down detection. For underground mines, we actually have developed a tracking system based on 3GPP standards, allowing mining companies to track machine and warn proximity users in real time. This is actually connected to the Mobilers platform that Tim just mentioned. So really the system is composed of a real-time tracking engine and 5G chip, which is embedded into the cap lamp of the worker. So the workers are always connected. We can send messages to the cap lamp. We can receive acknowledgement from the workers. So it's really a bidirectional real-time communication with those workers. So they don't even need a phone, and they're always connected. Some other examples are ruggedized IP67 modems that can be installed on mining machines. So we have small one, we have big one that can be connected to pumps, to Modbus, to machine. So there's actually a lot more devices out there that can be connected, and that will increase in the upcoming years, as we mentioned before.
Great, thanks, Eric. So let's talk a little bit about how to start validating this new technology. So Robert, if a mine wants to validate if the technology works for them, what are some of the options that they have?
Yeah, good question. It goes into some of these use cases, right? So understanding what the challenges of that particular mining company is looking to overcome, whether that's worker safety, big issue there, environmental constraints that are sitting there. Got to navigate the regulatory environments as well. And there are different ways to kind of instrument these purchases. We're very open-minded to changing our business model based on what challenges our customer has, either as a managed service type offering or as a capital investment. So depending on what the customer's challenges are, again, we're trying to be really flexible about it. Some of the use cases that I think our customers need to get started on are mission critical capabilities, the ability to drive some intelligence around your situational awareness, as mentioned by Tim, I think is a really good place to validate and start. But I would pick those 5 use cases that we talked about in the beginning, try to double click into worker safety, how you're going to improve your operation on analytics using some of the asset inventory management, predictive maintenance type solutions. That technology exists today, but taking that into your mind could have material benefits to your operation, right? Producing more with less is all about the mining game. And I think, the digital transformation is all ready to help, help these guys out, help lean in on this thing. So that's kind of how I would think about it if I was inside a mining kind of strategy session or a business planning session at some of the customers. I would pick one of those 5 areas and go explore it on a proof of concept and see if they can make the numbers work for them.
All right, great, Robert. Next question is for Tim, and I think we touched a bit on this already, but as a mine starts to enable the 5G ready technology, what are some of the benefits that you can see of adopting this technology, some of the early benefits?
Yeah, I think the early benefits right away are bandwidth and quality of service. The miners want productivity at low cost, and they're starting to embrace lean technology or lean principles, lean thinking. So they're wanting to reduce their WIP and a bunch of other things. And to do that, they need to understand unplanned downtime of the assets more. So to be able to reduce your work in process and your amount of equipment, you really have to manage that unplanned downtime, which gets right into what Robert was saying, into the analytics and condition monitoring of the equipment. Epiroc, we've released a product called real-time data where we can stream data off the machines. And when we first tested it at one of our customer sites, we turned everything on at 1 hertz, and we couldn't get all the information off the machine. It was too much. So having an increased bandwidth or even a quality of service to ensure you get that information off of that machine is what the miners are going to want. And, in a perfect world, they're bringing the data scientists in, and the data scientists in a perfect world would get very high frequency data off of every possible data source on a piece of mobile equipment or even fixed equipment. So having 5G to have that again, the bandwidth and quality of service, those are the two things that I think the miners are going to be able to leverage right out of the box very quickly to benefit their operations.
Perfect. Thanks, Tim. Now we are coming to the final fire chat question before we go into the Q&A. And Eric, as we are putting together these systems, we need to integrate with the IT and the OT systems. Can you talk a bit about how that works and how we do that integration to draw this benefit from the connectivity?
Yeah, definitely, Per. Well, integration is a very important step, as IT and OT, they have different requirements in terms of mobility, maintenance, and redundancy. So usually the OT network will carry the voice, the mission-critical traffic. So usually if the OT network is down, the mine probably will shut down. So it's really important, really, that we do data segmentation and we make sure that we fulfill all the security requirement for both OT and IT. So usually what we're going to do is we're going to deploy and define multiple VRF, multiple APN, depending on the application. So the actual infrastructure will be able to carry both traffic in a really secure way, by the way, and still being compliant with all of the security requirement. The SIM card usually is used to authenticate the device and will be programmed to work with a single APN. So there's no risk of having like OT traffic being bridged with IT traffic. It's fully separated, basically. And all the traffic over the air is fully encrypted. And again, in terms of redundancy, usually every implementation that we do is fully redundant. There's no single point of failure. And all of the critical components that are needed to operate the 5G-ready network are typically installed on-premise in 2 different data centers. So this is usually how we do integrate both IT and OT network.
Perfect. Thank you, Eric. So thank you, Robert, Tim, and Eric for the fireside chat here. And we have quite a few questions that we have received in the Q&A. So we will continue with those. And as we go through those, we may not have the time to answer all of them, but we are available to answer any further questions, as well as you can contact the D-15 with additional questions. So Brian, I'll hand it over to you to touch on some of the questions that we have received.
Absolutely, Per. A lot of great questions. Maybe we'll start with you, Robert. For the mining using endpoints to connect to the macro network as well. For instance, trucks that leave the private network and still need coverage.
Yeah, so depending on what the customer use case is, but you do need, in some environments, to go off campus or outside the premise of the mining facility. So in that, you want some redundancy. So you can have private networks, and you can also have them kind of falling back to the macro, so you can track assets in and out of the environment. And so goes into some of the design that you're building into your network environment. It's one of the things that we do really well at AT&T with our engineering groups and our partnerships with Ericsson, as a matter of fact, and building indoor as well as outdoor and redundant networks to give the customer what they need.
Great, thank you, Robert. Maybe Tim, a couple of questions that maybe I'll combine here for you. What kind of technology are you using to track equipment and assets, and what type of software do you use for automation?
Good question. So I'll try to break that down. For tracking assets in a mine, we would recommend our partners, both ASI Mining. They use their Mobius software platform that'll give, for surface mining, a mine map. And it can show all the different assets. They offer GPS kits, both differential GPS, high precision and low precision, that you can put on your assets to track it, and then you'll get the situational awareness with the Mobius mine map. For underground, our partners Mobilars have their system as well that works in a similar fashion, but it's a 3D underground map showing where your people and your assets are underground. So those are those are the two products that Epiroc is using today for that. And then the second one, you asked about what software we use for automation. Is that right, Brian?
That's correct.
Okay, so it's hard to answer because there's lots of different pieces of it. But the onboard machine automation software, it's all coded in C++. And so it's our proprietary software that Epiroc has developed for the on machine. When it comes to command of a fleet of machines, we are using Epiroc proprietary software for that as well. Some office tools in C# that we've made. Our tool is called Surface Manager. And so that provides that command layer to manage a fleet of autonomous drills. So that's about as deep as I can go in the time I have, Brian. Otherwise, we'll be here for another hour.
No worries. Thank you so much. Eric, a question for you. You mentioned that no mine wants to be first. Do you have any mines that can serve as a showcase for connecting technologies at surface and underground mines?
Definitely, we have a lot actually. So we have a lot of open pit mine that we've been migrating from Wi-Fi mesh to LT, and then we have, as I mentioned, over 500 kilometers of underground tunnels covered, and this is span over multiple underground mines. So I'll be more than happy to even connect mining companies together. So you can talk to them directly. You can ask them, hey, how was the migration? How are you doing today? So I'll be more than happy to share those contacts to those who are interested of having those contacts. But yes, we do have a lot.
Great, thank you, Eric. Robert, maybe another one for you. Can you describe a typical edge computing setup for a mine? And do miners prefer an on-prem server, or can they work over a neutral host or public cloud environment?
Good question. So more and more of our customers are looking at localizing their network and maintaining the complete privacy and control. You know, if the data coming off the devices doesn't need to go back outside the four walls, then it shouldn't, right? And so what you get with that is a closed loop system that's super secure, and the latency benefits are great. You know, 10 milliseconds or less latencies, just removing that hops is tremendous. So when you think about that, you've got endpoints and access points all self-contained, and your edge compute platform, the server infrastructure sitting there, gives you that security and that performance that you're looking for. Then when it comes to the cloud, it can really be public or private. And so if that application data is getting crunched locally, and there's a security posture that's got zero tolerance to it, you'll want to put that cloud, likely private cloud, sitting on premise alongside the edge compute box. There's different ways to design it based on what the requirements are of the customer, what their security stance looks like in general, but localizing everything is certainly one of the leading customer solutions that we design and implement.
Great. Thank you, Robert. Maybe a question for the panel as a whole. Someone asked if it would be interesting to know if AT&T, Amber, or Epiroc has any thoughts looking into NRU and its possibilities. Tim, Eric, any thoughts there?
Can you repeat the question, Brian?
Yeah, sure, absolutely. It would be interesting to know if AT&T, Amber, or Epiroc has any thoughts looking into NRU and its possibilities.
Can you expand maybe on NRU so we can maybe provide like a more detailed answer?
Yeah, they didn't provide, so maybe we can follow up on that one. Another question that I think is I think a good general one. What are some ways that 5G mining can help with sustainability for the group here?
Well, it's definitely a more efficient technology so going to 5G will be more efficient, requires less equipment, so less power consumption in some of the case. So that's where we see the switch going from 4G to 5G. There's a lot of benefit, and we see right now already those benefits out in the field, actually.
Yeah, I agree. The same thing.
We're wrapping up here, Per. So I don't know. Oh, Tim, go ahead. Sorry.
No, I was just going to say the same thing. I agree with Eric. Knowing where your assets are in your mine, you can greatly improve efficiency and short-term planning. So you can reduce the wasted energy and really, maximize your short-term plan just by knowing where your assets are, so you can efficiently move them around your mine.
Great.
Yeah, it's the same point on the NRU question, right? So the ability to take your licensed, unlicensed spectrum, whatever it is, based on the customer requirements, and utilize it as efficiently as possible. That's really what the end game is. I think Tim said it best. These customers are looking for high productivity at low cost, right? I mean, that's the name of the game here. There's probably a safety element inside that too that goes into it with cost and safety, but 5G technology, 5G NRU, all aims at a very efficient, high productivity, high availability network.
Great. Thank you. Robert, Eric, Tim, thank you guys so much for being on the panel today and for joining us. And all of you who joined, thank you so very much. And if you have any additional questions, the email and contact information for is in the chat. And have a great afternoon, evening. Thank you so much.
Thank you, everyone.
Thanks, everyone.
Yeah.
Thanks, everybody.
Thanks a lot.
Thanks.